Doing some spring cleaning. Not immediately. Oh, I gotta fix my webcam. I have to compromise between having the camera point at my face and having the camera be in the middle of the screen, so that looking at the monitor, it looks like I'm looking at you. If you were hearing that horrible whirring sound in the background, that is a Roomba, which we just have kind of run in the basement. Good morning, Katie. Good morning, everyone. I have a cat, so since I'm living with my parents right now, the cat is kind of making his mark on the house, shedding everywhere. So we leave the vacuum running down here quite frequently because otherwise there's just hair everywhere. And my mother is allergic, which I actually am as well, but she's more allergic. So we always have stragglers, people who trickle in kind of at the last second. So I'm going to stall for a few minutes, wait for people to show up, because we need to talk about announcements today. But while we do that, in honor of the special day that it is today, April 20th, I thought that I would share some of my plants that I'm growing at home. So, in case you only know one plant that exists in the world, I can provide some others. So these are little plant pots that I have, bought them at Home Depot. This is a Japanese maple, little baby Japanese maple sapling. It's about 6 months old. My mother found it in the yard a couple days ago, and so I've planted it in a little pot here, and then it needs about 2 to 3 years to grow before it can start being shaped, meaning it will need to reach 2 to 3 years of age, so 1.5 to 2.5 years, and then I'm going to pot this into a bonsai pot and begin shaping it into a Japanese maple bonsai. But that's, of course, quite a bit of time away. If I were to be really patient, what I would do is actually plant this in the ground. And they are delicate trees. They're not that delicate. It is interesting, though. They prefer a different kind of soil to a lot of other plants, which is very interesting. So I need to look again, but I think they said they preferred very acidic soil, between a pH of 3 and 6, which is pretty surprising. That's like stomach acid is like a pH of 3. Like it's pretty dang pretty dang acidic. There are other restrictions as well. Particularly for bonsai, you have to be really careful with your soil. I'm just using potted soil right now. Yeah, they do. They're definitely different. I've actually had my eye on a Japanese maple. I particularly wanted to do a Japanese maple bonsai. Now, I had quite a bit more seedlings. I had started a little vegetable garden, and then I left my seedlings outside at my mother's suggestion to get some sun. We had a storm coming in, so I moved it under the deck, and apparently that was not enough protection, so I lost a lot of my seedlings, but I still have a few onion seedlings left. Oh, and there's dirt falling out of the bottom. Onions require well-drained soil. These have the large holes in the bottom. There's kind of some dirt falling on my keyboard. But some onions. And then the last remnant, I have a lettuce plant that's trying to survive. It looked much better before the storm, I promise. And then this little guy right here, I think, is a China aster seedling, the one in the back. This little guy right here is a China aster, which is a flower. And interestingly, in the wreckage of the storm, it actually managed to germinate. So it was as the other seedlings died, it sprouted. So that was interesting. So we're not up to 22 viewers. We're ready to start. This has been your April 20th tree presentation. I had some other stuff, but I have a handful of things here. I got a little potted plant and some other stuff that I thought about showing, but we need to move on. We'll come back to these dates here in a second. Let's hop into announcements. While I'm pulling up the announcement, the first thing that I'll tell you is I have added a new widget to our stream. So you see this big shaded block up in the corner? This is a Discord chat integration. So just for example, if I bring up Discord, please let me take the window. Thank you, Discord. Okay. I go to our class, and if I type in example message, see, look up here. Rob Cook, if I type in example message, it appears up in the top corner. So this is another way you can type in the chat and I'll see it. I've been fiddling with the settings on how much opacity and stuff to include on this. So if it's hard to read, we can fix it. That's one thing. Okay, so largely what we have on announcements today is just kind of schedule for the last 2 weeks, because you heard it right, folks. This is it. Last 2 weeks. We have 2 weeks remaining. That's counting finals week. So we are very nearly out of here. But as you may imagine, there is quite a lot to cover in the meantime. There are 3 things, and then upcoming announcements are on the next slide. So I put this big obnoxious thing, so hopefully people who just glance at the announcements later won't miss it. So climate study is due next week. Last day it is available is on Monday, which is the last day of class. Restoring MindTap access instructions posted to D2L. My impression is that that this often doesn't work if you go through D2L and try to refresh it. You have to go directly. But I know of a handful of students that did that and it still didn't work. I don't know what the exact problem is. I'm still working with them on how to fix that. So if you're one of those and you emailed me last night at 10 p.m. or something, I haven't gotten to your emails yet. I'm sorry. But the point is that I've made an accommodation for everyone. I know a lot of people have been having some frustrations with this. If you still haven't gotten it figured out and we've been in contact, I do hope you're looking through their support, because I don't know how to do it. I emailed them. This is what they told me to do. So it wasn't much. 3 slides of PDF. So the only main tip I have so far is to go there directly. And I think I put a link in the Discord. Maybe I put it, if you need the link and you don't have it, let me know. I put it in the Discord, but I might have put it in one of the other sections and not yours. Okay, so I told you about cherry picking concepts before. We're still going to be doing that in basically the same way. We're skipping finite populations, which is mostly relevant for Chapter 7. And then we're not going to do population proportions for anything. We have a good bit of Chapter 8 left and all of Chapter 9 left. And unfortunately, Chapter 9 is pretty much, there's only a few slides of population proportions, so we need to do a lot on that. So we'll need to be quick. To vocab quiz? Yes, you do. So, I'm so glad you asked. Let's look at the upcoming schedule. Now, there's a lot here. I'm going to zoom in and cut off the April 15th because there's a lot to go over. It's not as intimidating as it looks, I promise. When I looked at this, I was like, oh my gosh, there's a lot. It's not as bad as it looks. Okay, so you have homeworks. That's like almost half of the slide. That's a big chunk of the slide. Chapter 7, maybe you've already done it. You've probably already done it. Maybe you haven't. That is extended to Wednesday, the 22nd at midnight. So if you haven't done the homework yet, please do it by Wednesday. If you're still having trouble and you need an additional deadline, I've heard that the support lines are like 2 hours long. If you need more time, we can get it to you. Chapter 8, I will make available to you this afternoon. That will be due on Sunday. I'm trying to kind of spread it out. Chapter 9, I will post Wednesday after class. I do not expect you to be able to finish it on Wednesday, but I'm going to go ahead and make it available anyway. So you'll notice there's quite a bit of overlap here. But I want you to go ahead and have Chapter 9, even though I don't think you're going to be able to. I think you'll be able to do probably about half of it by the end of the day Wednesday. That's kind of what I'm thinking. But you can at least get started if you want. That will be due on Tuesday of finals week. So I'm trying to enforce some pacing here, even though these might be odd days, but I want you to have some flexibility to work on stuff. So that'll be available Wednesday through Tuesday. In class this week, we have 2 vocab quizzes, Chapter 8, Chapter 9. Obviously, starting with Chapter 8, there are 9 words, and there are 10 words of Chapter 9. Vocab quizzes each day. I will give you an in-class assignment, which will be over Chapters 8 and 7. I might sprinkle a Chapter 9 question on there, depending on how far we get in class on Wednesday. But right now, I'm thinking just Chapters 7 and 8. And then we will do an open book, open notes quiz on Chapter 7, Chapter 8 on Monday. So we'll finish Chapter 8 today, I expect, and then we'll have a week to do homework, in-class assignment for practice, and then the quiz on Monday. And that'll be Chapter 7, Chapter 8 only, no Chapter 9. That's quiz number 2. So the in-class assignment number 2 is going to be a regular assignment. It'll be kind of like the exam was. It'll be on D2L. You can fill out some questions, sort of like a mini practice exam. Ooh, I meant to put that on the slide. Forgot to. I was kind of out of space anyway. Yes, you'll have a practice exam for the final. I said it last time in class, but just saying it again. In-class assignment 3. I promised you 3 in-class assignment grades. So the third one, I'm basically going to give you an exit survey specifically regarding your experience with online software. I've been in some discussions with the administration, university administration, indirectly, about what softwares I've been using. This is obviously something of interest to the university in these difficult, unprecedented times. And we're trying to learn from the experience and to use it going forward in online teaching to make our online teaching better as a university. So as far as I know, I'm one of the few who are using Twitch, and I'm not sure of anyone else using Discord. So the administration is particularly interested in how our experience has been. So please answer honestly. It's a completion grade. You're not going to hurt my feelings. I had a lot of mixed feelings on what softwares to use. I thought this was the best, from the front end of things. There's obviously some downsides. That is actually going to be one of the questions. Would you rather do this than Zoom? That's your opinion. I'm glad to hear that you like this better than Zoom. Anyone else? Feel free to disagree. Please be honest, because I want to go to administration with this. Good, Nicole. I mean, I'm glad to hear that. But again, be honest with me on the feedback, because whatever you tell me, I'm going to take to the administration and say, here's what my classes said. So please be honest, because if you answer dishonestly, and you take me again for online classes, you might get stuck with something you don't like. So please be honest. You're not gonna hurt my feelings. I promise. I do not care what you say. I just want you to be honest. Just filling it out, you'll get credit for the assignment. I don't care what you put. So just answer the questions, but please be honest. It's not gonna be long. It's gonna be a handful of questions, and I'm gonna try to make them pretty straightforward. Zoom's laggy. Interesting. I haven't really had a chance to really compare and contrast those. I did do a little bit of Discord versus Twitch versus other things, and how much lag do I have, for example. So I was able to measure. It's there's actually a tool in the gear at the bottom of the stream. You can see exactly how far behind me you are. It's a little over 2 seconds. Is all the time it takes for my computer to package, send to Twitch, and have it dispersed to you. It was pretty close. It's pretty fast, I think. 2 seconds is pretty impressive. So anyway, I'll have this available to you probably this weekend, and then it'll be available about a week. I just need to have it in time for me to put the grades in, in a couple weeks. So I'll give you your exact dates on Wednesday. You've got enough to worry about right now. I'd rather it be due later rather than earlier. But there's going to be another end-of-semester survey, so I actually thought about incorporating this in-class assignment 3 questions with the end-of-semester survey. I didn't. So the ICA 3 is required in the sense that I'm giving you a grade for it. It is not anonymous, so not that I care. I don't care. I really don't care, so I just have to tell you it's not anonymous. So I'll know who said what, but again, I don't care. I'm not going to punish you for one thing or another. I don't care what you say. Just be honest. The end of semester evaluations, how's this Rob Cook guy? Is he a good teacher? Was he prepared for class? These kinds of things. Obviously, it's much easier to hurt my feelings with those, obviously, which is why it's anonymous. I'm usually got a pretty thick skin about it. I have an opinion about how prepared I am, etc. So but it's good. This is another chance for you to be honest. I've said in class before that if you are incredibly dramatic, people don't take you seriously. So be honest here too, because generally people can tell when you're lying. It happens. People lie on these surveys, and it's usually pretty obvious. So, again, honesty is valued here. Please be honest. Any suggestions, criticisms you have that I can improve on are appreciated. So, and these are reviewed. These are part of my evaluation package every year. So these do get sent around to everyone in the university, and they're reviewed every year, at least for non-tenured folks. They're reviewed every year, so they care what you say. But again, if you exaggerate to the extreme, and it's obvious that you're lying, then no one takes you seriously. So if you're honest and you have an honest criticism, that's much better than a dishonest criticism. Now, some things you need to know about the end of semester surveys. Number one, they are due Monday of next week. This coming Monday the 27th. I think they're due at midnight. I don't want to promise that, but I think they are. An incentive. Now, I have no idea who filled them out, but I can pull up a thing, and it gives me a big green number and tells me how much of the class has filled it out. If we get to 80%, then I will drop your lowest quiz. Now, we are going to have a third quiz during finals week, which means that if you don't want to take it, it'll be optional. If we get to the 80%, it'll be optional. You don't have to take it. It goes away. Or if you want to take it, it'll be available for a handful of days. You can take it, and if it's better than one of your other two quizzes, then you will get an improved score. Of course, you don't have your quiz 2 score yet. I'll have to make sure you get that in the next several days so that you know what to deal with. So as for quiz 3 and exam 3, those will be during finals week, and those will be flexible dates and TBD. I haven't decided if I want to make you do quiz 3 and then the exam, or if they'll be available all at the same time or whatever. I'll probably just say they're all available at the same time, and just kind of I'll let you guys figure that out for yourselves. Meaning you can decide when you want to take it. Is what I mean by that is it'll be flexible, so that I won't tell you like this is when it has to be. We do have an officially scheduled exam, so I could theoretically do that, but because everyone's work schedule is crazy, I don't really want to do that. So I'd rather just make it flexible. So I will continue to consider exactly what we're going to do here. We've got plenty to worry about, but yes, there is a third exam. I'm forgetting entirely. I've just realized. Will there be another exam? Jaysha, your question may not have been the way that I heard it, because I'm completely forgetting that we need to have 2 exams. So exam 3 is non-cumulative, and it's amazing why I'm just now remembering. Anyway, brain. We need to have a 4th exam. So my original plan, which I did not put on the slide because I wasn't thinking about it this morning, is that exam 3 would be available through, say, Friday, just as an example. And then depending on how you do on Friday, you would be able to take the final exam, or which would actually be possible for me to, you can take. There are alternatives of what I can do, so I need to think about this because I obviously forgot about it. But so obviously you'll want to do the final exam after exam 3. It doesn't make any sense to do it before. So exam 3 is required. The final exam is optional. And I'll need to think about how we want to balance that and how we're going to do scheduling. Because the whole sign up for your exam slot, very mixed reviews, which I think I put that on the quiz that I was going to give you guys. Where's my quiz list? Yeah. On the in-class assignment 3, I'm going to ask about the flexible sign up. I don't know. Some people that's what I thought. I didn't think it was that complicated, but some students got really bent out of shape. A handful of students were really upset about it. So, and on one hand, like, I want to have your reaction and be like, wow, you were really over dramatic. But, there's enough new right now. We've got enough new. I don't want to make things more new. So I'll think about that. I'm trying to decide how to balance it. Maybe what I'll do is just say like, hey, this is when you can take it. And then if you don't like that, you can just tell me and I'll change it. So I can be a bully, or I can like fake being a bully, and then you can just tell me if you want to change it. That might work. I'll consider that. Okay, that's everything for today. Let's get moving. We need to do vocab quiz. Okay, chapter 8, vocab. Oh, why are my things inconsistent? No, this is unacceptable. Vocab Oh, caps lock. You Larry quiz. Cool. I need to change the dates anyway. It's available. You have the next few minutes to get started. 12, 15. Okay, please get started right away. Your quiz should be there. Good luck. Gambate. Do well. Do your best. As usual, I'll mute my system sounds. Oh, they're already muted. Whoops, forgot to unmute them last time. My system sounds are muted, so you won't hear the dinging in the chat. If you have any questions, I'll be here. Please put it in the chat. I'll be off mic for a second. And I'm going to put my saplings outside while you get started. Okay, so by my count, that's everybody in. I have 24 viewers on my Twitch dashboard according to my phone here, and 25 vocab quiz submissions. That's a good sign. So I'm gonna take it that everyone is finished. If you're not finished, feel free to keep working. I'm sorry for talking over you, but we got a lot to do in the last week, so I want to get moving. We're not all just sitting here. As much as I just had a lovely time playing with my cat, which of course I'm now absolutely covered in cat hair, but I did brush him a little bit because the poor thing is basically like he's kind of like a sheep. If you don't shear him, he's really poofy even if you do shear. I'm using a brush. Sheer, big quotation marks. Anyway. Okay. By the way, if you're bored, if you're one of the few who, I shouldn't say few. If you're one of the folks who's really bored right now, and you need something to stimulate your brain besides this class, which probably you got all you need, I recommend this YouTube channel, the Cracking the Cryptic. It's like creative puzzles, and dang, they're hard. I worked on this one for 3.5 hours yesterday. The timer's still ticking because I had it open before that. I couldn't go to bed last night because I was like, gotta get it. I didn't. I made a mistake. I solved the dang. Okay. Cat. Okay. I solved it, but I made a mistake. And so I started over. Okay. The cat is hanging out on a ping pong table, and my dad left some little Allen wrenches, and he's like, "Oh boy!" And so he's doing the cat thing. And as you might expect, it makes. You gotta see this. You're on camera, buddy. My little munchkin. Anyway, so chapter 8 is where we left off last time. I'm going to have to take those away if you're going to keep making noise. He's so cute. Oh, it's so hard to tell him no. Oh, of course. That's what happens. Like I said, I'm allergic to cats. But I love him. Okay, that's really loud, though. I don't think you guys can hear it. This mic is good enough at cutting out the background noise, but I certainly can. Okay, please don't eat it. All right, hold on. Okay, sorry about that. He had it in his mouth, and it's a big enough wrench that it's probably fine. But if it weren't fine, it'd be really not fine. So, okay. This is where we left off on Wednesday. It's been several days, of course, so let's go back over it. Basically, we were talking about how to take the estimate that we get for a population parameter and use the information and the variance of either the population or the variance in the sample to give us an idea for what the true values of the population parameter might be. We have an estimate, and then we provide an interval that is and it's sort of in a sense, it's a more specific estimate. So our first estimate is like, oh yeah, it could be this. But then our interval says it's somewhere between here and here, probably. And that actually is a lot more useful than just knowing what, a kind of a point of some sort of central tendency is. So, okay. By the way, I feel like I should ask. I've messed up enough vocab quizzes. Did everyone who thinks they got 100 get 100? Did I do it right this time? I probably need to go back and check, but just to make sure. I tried to verify. I previewed the quiz, made sure all the answers made sense, checked all the settings. I'm hoping to get the hang of it eventually. You'd think it'd be easier than it is. For some reason, it's not. Okay, so here is where we're going with this. So we talked about conceptually these intervals and kind of the concepts concepts of how this works. How do we actually do it? Well, so it turns out that we actually don't need anything new. We've seen all of these terms before. or at least before today. So we have x bar, which is our sample mean. It's the thing we computed when we take our sample. Nothing new. 1 minus alpha is our confidence coefficient. We explored this some last class, and it was on your vocab quiz today, so hopefully you knew that. I'm sorry. I'm not swimming through the air. There is cat hair floating around my face, and as you know, I'm allergic. So I'm trying to pick it out of the air and put it down towards the carpet. So sorry about the distractions. Okay, 1 minus alpha, confidence coefficient. Z, alpha over 2, is your Z value, providing an area of alpha over 2 in the upper tail of the standard normal probability distribution, or lower tail. You can kind of look at it either way. It's the same. If that part isn't familiar, go back and look at the end of our lecture from last time. Of course, all of our lectures are available for you on demand, VODs, videos on demand, on D2L. Feel free to look at those. I'm sorry they're not cut down, by the way. I'm trying to requisition video editing software. I don't have anything. And I might be exploring free options. I was hoping I could get a commercial one quickly, but that's apparently not happening. Anyway, okay, so sigma is our population standard deviation, and n is the sample size. So if you recall, we saw this part before, sigma over square root of n. This is the this is the standard deviation of the sampling distribution. That's the formula. Sigma over square root of n, sigma over radical n is the population of the sampling distribution. So you can just as easily write this, can I have my pen please, as x bar plus or minus z alpha over 2, which some people will write a strike through the z to differentiate it from the 2. I try to use the little swoop, writing with my mouse. I'm not very good at it, so it's not very obvious. Anyway, and then this is times sigma x bar. So you can use sigma x bar in place of sigma over square root of n. It's the same thing. Doesn't make a difference. Okay, but again, this is a formula. It's important that you know what all these things are so you know how to plug it in. But it's that simple. You plug it in, get the answer, write it down. Really, that's a lot of Chapter 8, is this formula right here. So how do you use it? What do the numbers go in? That's pretty much the rest of today. That's what we're going to talk about. How do we plug the numbers into this formula? It's not that complicated, but it is unfamiliar. And I say that a lot in this class because there are a lot of things that are really quite simple. This is just 4 numbers. This is a number. This is one number. It looks like several numbers, which it is, but it becomes just one number. So I guess it's, another number, which becomes another number, which becomes another number. So, there's some steps here. But this is really just number plus or minus number times number over square root of number. So if you learn how to plug this in, and we've already done this, we've already done this, we've already done this. So really this is the only new thing, and we did that last time. So there's nothing new. We're just putting them into a new order, to a new sequence. So it's new. It's unfamiliar. It's a new sequence. So for that, it may be intimidating to you. It may not be, but it may be intimidating to you, but it's actually simple. So once you get the hang of it, it goes quickly. So a way to make this go a little more quickly. Here is a cheat sheet, which given that the remainder of your assignments are open book, open notes, I'm just saying. What can I say except you're welcome? I won't sing it to you, but, I'm tempted to, but I won't. I will not insult the rock like that. Okay, so here's a cheat sheet. If our confidence level is 90%, then alpha is 1 minus 90%, which is 10%, 0.10. Which, by the way, this came up on the exam. If you are being asked to enter, what percentage, blah, 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 on an exam, and then I say, express your answer as a decimal. What that means is, if your answer is 10%, enter it as 0.10. That was definitely an issue for some students on the exam. And if you didn't get it fixed, I tried to go back and give partial credit. If you mentioned it to me, I did not review them all manually. So if this happened where it said hey, what's the percentage? And you wrote 10, 10 is not a percentage. And in the system, you cannot type in 10%. That won't take it on the formula questions because that's not a number. 10% is a text string because of the percent sign. So you have to enter it in decimal format, 0.10. So just be aware of that for the future. And if you made that mistake on the exam and lost points for it, let me know. I'll try and give you some partial credit. I can see that you did not made that mistake. Okay, so that's alpha, 0.9 minus 0.1, and then divide that by 2, you get 0.05. And because that's 0.05, that's the distribution, that's the percentage in the right hand, so we do 1 minus again, and we find 0.05, 1 minus 0.05 is 0.95. So we're going to be looking up 0.95 on the z table, or you can look up 0.05 on the table, and that'll give you a negative number, and you flip the negative to the positive. So you can look up 0.05, and you'll get negative 1.645. So you can either remember to look up this and then take the positive version, or you can subtract this from 0.95, and use this number. Or more likely, truth be told, I'll probably use one of these 3 confidence levels. So you can just use the table. If you know it's there, okay? I'm warning you. Bookmark this, print it out, circle it, highlight it. I don't care. Do something. Print it on your ceiling. Something. I don't care. Just, put it in a bag. Get it together, Summer. I don't care what you do with it. Take it down to the store. You're welcome. Look, what can I say except you're welcome? I'm not trying to say that I'm a demigod. I don't have nearly enough tattoos. Or that beautiful caramel skin. Man, I missed out on that one. Got Native American skin, so it's hard for me to get sunburn. That's nice, but oh well. I feel like everyone wants that skin color. Like, white people tan for it, I guess, That being said, a lot of populations I feel like can't change their skin color very easily. I never thought about that before. Some people just burn. Oh well. Such is life. I tan, but I work inside, so I don't. Anyway, like my tan lines. Ooh, really not that bad. I'm just white in general. Anyway, so let's see. What does confidence mean? Okay, so I honestly don't want to spend much time on this because I told you before that I actually took a statistics class from one of the authors of our textbook at Alabama before he got promoted to whatever fancy position he's in now. And this is a big pet peeve of his. And he actually doesn't like it being said this way, but he knows that it's done for introductory classes, but he hates it. And so I used to get on a soapbox on his behalf for it, and it's just not worth it. So basically, what we say is, we have our confidence, like 95% confidence or 90% confidence. And so what's really happening is 90%, if we're using 90% for an example, 90% of all the intervals constructed in this manner, meaning you take a sample in the same way, you compute the average, you compute the sampling and distribution standard deviation, you use the 1.645, the value from our table before, which, by the way, just kind of point at it again. Look, 90% confidence, 1.645. That's how it works. Confidence, z value. And then you just plug it in the formula, 1.645. Okay, so 90% of all the intervals we construct in this manner will contain the population mean. So we can say that we're 90% confident that the interval x bar plus or minus 1.645 times the standard deviation of the sampling distribution includes the population mean mu. However, technically, this is wrong. Technically, this statement is wrong, but it's not worth explaining why. You know what? This is one of those things where it's like it's a social convention. People say it this way. It's wrong, but we say it that way. And that's just kind of how it is. For example, I noticed this in myself. Hey, where are you at? Not grammatically correct, but yet everyone knows what I mean. And so I say this frequently, despite my general attempts at good grammar. There are certain things, hanging prepositions like where are you at? Which, by the way, it should be where are you at? And I just say, where are you at? There are at least 2 grammatical mistakes in that sentence. And yet it's accepted. So I'm proposing we do that with this. It's wrong, and let's just not care. We can say that the interval's been established at the 90% confidence level. That's not super useful. This is the confidence coefficient, 0.90, the decimal version of the percentage, whatever. Vocabulary terms, I don't want to focus on it in our accelerated semester. Okay, example time. Discount Sounds. Discount Sounds has 260 retail outlets available throughout the United States. The firm is evaluating a potential location for a new outlet based in part on the mean annual income of the individuals in the marketing area of the new location. A sample of size n equals 36 was taken. The sample mean income is $41,100. The population is not believed to be highly skewed. The population standard deviation is estimated to be $4,500, and the confidence coefficient to be used in the interval estimate is 0.95. Now, before we move on, let's review our table. A confidence of 95% corresponds to what class? 1.96. 960 to be precise, but we're going to use 1.96 for our z alpha over 2. So, when we plug into our formula, we'll use 1.96 x bar plus or minus 0.91. Let's go ahead and write this in there. Can you vote? You can vote, but I will reserve the right to veto. .96 sigma. I'll tell you a story about my accents sometime. I've done this random thing several times. New Zealand. So, okay, so you see here we've got x bar plus or minus 1.96 times sigma x bar. And that's what we're going to use for this example problem. All right, so, okay, I already read the introduction. Let's get into it. 95% of the sample means that can be observed within 1.96 times sigma x bar of the population mean mu. The margin of error is therefore z alpha over 2 times sigma over square root of n, which of course we can plug our numbers in. Z alpha over 2 is the 1.96. I'm sorry. 1.96. That's this number right here. So we just plug that in. Goes up here. And then we plug in 4,500 is the this is the sigma. Remember, if we go back, right here, sigma, standard deviation estimated to be 4,500. What else we need? Sample size 36, not 36, 36. New Zealand is not British, and they have, unlike Australia, they have no connection to the British, surprisingly, so they do not have British issues. Rugby. Yeah, so like you can't pronounce a T, for example. Actually, my Yoda's not very good. I'll have to work on that. Practice, I will. Yeah, that's not very good. Okay, so we plug in 1.96, plug in 4,500, right? That's this one here. I shouldn't do that. Erase that. Okay, so these two numbers just come from the previous slide, and then you type it into the calculator. 1.96 times 40. In fact, just for giggles, for kiggles, kicks and giggles. 1.96. Oops, that's a 3. 96. Let's see. We're actually, so this is a little tricky. We're gonna need to do 36 square rooted, which of course you might have just done in your head. It's 6. Okay, but just so you see how you do this. So you add this to your memory, and then you go back to the beginning. So then you can clear it out. 6 is in the memory, and then you do 1.96 times 4,500. That gives you the multiple, and then you divide by the memory recall, 1470. So if you didn't know how to do that kind of thing in a basic calculator, now you do. Feel free to watch the VOD. Watch it again in slow motion if that was too blindingly fast for you. 1470. Hey, look, we did it. That's how this works. Of course, with 36 squared, you can just, hey, look, it's 6, because it's a practice problem, so the numbers are easy. It's just 6. Okay. So we can say that at 95% confidence, the margin of error is 1,470. Cool. Margin of error, 1,470. Did I get it? Yep. Little cat hair. So we can turn our interval estimate into, so remember, what do we do with the margin of error? That is, it's x bar plus or minus the margin of error. Remember that? So that means we have x bar, which was 41.1. Is that right? Yeah, 41.1 right here, this number, 41,100 plus or minus our 1,470. So 41.1 minus 1,470 is going to be a little bit less than 40,000. So 39,630 to 42,570, right? 41,100 plus or minus 1,470. 39,630 to, so this is just this number minus that gives you this number plus that gives you that. So we can say we are 95% confident that the true population parameter, the true population mean, is between 39,630 and 42,570. So, by the way, you can enter the number like this in text form, 39,630 to 42,570, or you can write it in interval notation. Why is my cursor disappearing? Okay. In interval notation, which is 39,630 parentheses, I usually use a big comma just for making it obvious, 42,570. Now, if you're writing this in a computer or something, don't put the commas here. Just put a comma here, and that way you won't have a confusion because you can only use one size of comma. So just write 39,630, comma, 42,570, and just call it a day there. So that's your other way you can write it. It's the same numbers. It's the same information. It's just a different syntax, just a different format. Not important. Okay. Are you with me so far? Compute the mean with the estimate. That's the easy part. Use the table, which will probably have your z-value. If not, you can follow a similar process with a z-table to get yourself your associated z-value. And then you compute your sampling distributions standard deviation, and then plug it in a calculator, and boom. Yeah, it's certainly simple enough, and when you get comfortable, it will be easy, which is how most of life is. Okay, so just for comparison's sake, here are the different interval estimates for that particular example problem with 3 different confidence levels. So I gave you 90, 95, and 99% on the table. Here are their associated margins of error for this particular example problem and the associated interval estimate. So what do we see? Well, the lower bound from 90 to 99, the lower bound gets smaller and the upper bound gets bigger, which means our interval is getting wider. So in order for our confidence to increase, then the margin of error and the width of the confidence interval must increase as well. Right? So how confident are you that something is in this little region? Well, not very confident. How confident are you that it's in this huge region? Pretty confident, right? So that should hopefully make sense. If you think of the extremes, oftentimes looking at extremes will make the trends make more sense. Okay. So what do we need for sample size? Oh, let's talk about this. We're going to skip out. Yeah. We need to keep going. Okay. Sorry. I was thinking we were a different part in the slide. Some we are. Okay. So how much sample size do you need? Well, in most cases, for most applications, a sample size of 30 is enough. If the population distribution is highly skewed or contains significant outliers, a sample size of 50 or more is recommended. Most of the time, you don't have to worry about that. You have huge samples. But as long as the distribution is roughly symmetric, then you can get away with as small as 15. And if the population is believed to be at least approximately normal, then you can use pretty much any sample size that you want. Okay, now, that's the simple case. So here's the bad news. This is the more realistic case, which is slightly harder. It's really actually not as much more difficult as it seems. There's really just one little, it's basically an asterisk. It's an asterisk. It's not really that much different. So yeah, it's not that scary. It's going to look a little different. Don't panic. Okay, grab your towel. Don't panic. Which if you haven't seen or read Hitchhiker's Guide to the Galaxy, that didn't make any sense. But if you have, it was a reference. Or actually, even if you haven't seen it, it was still a reference. You just wouldn't have gotten it. Anyway, okay, so up until now, we've been assuming we knew the population standard deviation, or at least had a reasonable estimate. But if the estimate of the population standard deviation cannot be developed prior to sampling, if we cannot get a good estimate, then we have to use the sample standard deviation, S, to estimate sigma. Okay, so we're going to use S instead, and we're going to call this the sigma unknown case. So in this case, we don't have sigma. We cannot use the z-table. We do not know the population standard deviation. Instead, we are going to use something called a t-distribution, which conveniently enough rhymes with z. I don't know if that was done on purpose. I like to think that it was, but who knows? Which, by the way, we're assuming that the population is normally distributed. So if you look up a t-distribution, you actually want to Google students t-distribution, because the guy who invented it, William Gossett, was writing under a pseudonym. He called himself Student, like he signed his email, or he signed not emails, signed his letters and stuff as Student. And he is the inventor of the t-distribution. In his papers and stuff, he signed as Student, the founder of the t-distribution. So it is his t-distribution, therefore students t. I'm going to put it in the chat. It'll pop up over my head. Students t. Like this. Students t distribution. It is usually written as a possessive. Students t. Fun fact, he worked for the Guinness Brewery in Dublin, which is actually still to this day a leading statistical research facility. They do research into statistical theory to help them make better brew, make better beer, brew better. I'm not personally a Guinness fan, but for those that really like Guinness, people are often passionate. If they like Guinness, they love Guinness, and I don't think they'll be surprised. Yeah, isn't that so interesting? I think that's fascinating. Like, to this day, Guinness still has like leading statisticians, and that just doesn't make any sense to me at all. I don't know. Whatever, it's fine. To me, Guinness just tastes like soy sauce. It's like fermented soy sauce. I don't know. I love soy sauce. Don't get me wrong, but I don't want to drink it. Anyway, I recognize that that's a inflammatory statement. So if I've just set you off, I'm sorry. Okay, so t-distributions, back on topic. So t-distributions are technically a family of similar distributions, meaning that there is not just one t-distribution. It sort of works like the binomial tables we talked about a couple chapters ago, where you look up first the sample size before you look at the relevant probabilities or whatever. Sorry, is it probabilities and then sample size? I think it's sample size then probability. Can't remember. They're all things on the table. But in this case, we have to look up where we're going to be on the table based on three things. But since we have a two-dimensional table, that has to be broken into three different groupings. So which t-distribution we're looking at depends on a parameter known as degrees of freedom, which, as you hopefully know from your vocabulary, has to do with the amount of independent pieces of information, or the number of independent pieces of information that go into the computation of S. Now, let's stop and think for a second. What is S? What are we measuring? Really, S is a measure of the amount of difference between different values in the sample, right? So what do you need to compute differences? Well, you need to have two separate things to compare. But if I have three values, I can compare the first to the second, and I can compare the second to the third. So I can make two different comparisons. And in theory, you can compare the first and the third, but you can kind of catch the first and the third by comparing the first and the second and the third. It's all in there. So really, when you have three bits of information, you have this to that, and you have this to that. You don't need to worry about here to here for this purpose. Similarly, if we have a fourth, we can go here to here, here to here, here to here. If we have fifth, here to here, here to here, here to here, here to here. So in each of these examples, we have one fewer than the number of fingers I'm holding up available comparisons to make. We can compare the first to the second, second to the third, and so on. So the computation for the number of degrees of freedom is just n minus 1. So we can see that more degrees of freedom will give us more information. And so the more information we have, the less dispersion, the less dispersion we have because we know more about our information. And so the less ambiguity we have, the less dispersion we have. And because, so it's kind of like, how confident are you? Not very much, very confident. The number of degrees of freedom is sort of like the width of my fingers. So the more degrees of freedom we have, the more confidence we have in our predictive power, which means that the larger the sample size, the closer the t-distribution is to a standard normal probability distribution. So if we have a large enough sample, then it actually doesn't matter if we do not have the population standard deviation, because we know so much about the sample that we don't even care. It'll be approximately equal to each other. So if this in the lavender here is what a standard normal distribution looks like for a given parameter, then as we have fewer and fewer degrees of freedom, so this blue one here, kind of like a, I don't know, I'm going to call this like a cyan, might be like it's an aqua, probably what that is. So aqua here is 10 degrees of freedom. 20 degrees of freedom is the blue one in the middle. And of course, as we continue to increase the degrees of freedom, it'll get closer and closer to the standard normal distribution. So if you're a visual learner, that might be more intuitive, might make more sense than the description that I just gave. So the fewer degrees of freedom, the closer it is to a flat line. There are still so many hairs flying around. Closer it is to a flat line. Not that it's ever going to be actually flat, but it'll be close. And then as your degrees of freedom increase, it becomes closer and closer to the standard normal. So where does this break off? Well, generally we say that 100 degrees of freedom is the cutoff. So if your sample size is over 100, then the standard normal z value is good enough to approximate the t value. It's a negligible difference, and for the vast majority of instances, doesn't make a difference. So actually, this is represented. If you look on a t-distribution table, which I've got a picture of one here coming up, then there is the degrees of freedom will be listed as like 1, 3, 5, 10, 20, 25, 50, depending on the table. We'll have different lists. And then the last row usually will say like 100, and then below that, the actual last row will say infinite. So basically, between 100 and infinite is usually not much of a difference. We don't really care. 100 versus infinite is basically the same. And so those will be the same as the associated standard normal z values, which you'll see here in a second. So this is an excerpt of a potential t-table. Like I said, there's a lot of ways you can define the table. It's based on the creator of the table, not the t-distribution, to be grouped however you want. And so you can see like 50 degrees of freedom versus 100. Let's just focus on, this is area in the upper tail, so this is the 90% confidence. 90% confidence, which we already know the z value for 90% confidence is 1.645. So there it is. There is our z value. And then if we go up, it's only 0.15 different between the z table and 100, which is not that different. 0.15 is pretty close. And oh, by the way, 80 degrees of freedom is 1.664, is still really close to 100. Similarly, the degrees of freedom for 60, 1.671. So you see, it's not changing all that quickly, although as you start getting into the 50, okay, this is just a gap of 10, and it's the same, it's pretty close to the same gap we had before. So the fewer and fewer degrees of freedom, the difference sort of accelerates. So the important thing here is to have as big of a sample as possible, and if you have reasonably over 100, you can just use the z-distribution, and it's close enough. But if it's fewer than 100, you have to use the table. Unfortunately, because the way the table, you may have 95 as your degrees of freedom, and that's not on the table. It's not here. You've got 80 or 100. Those are your choices. So obviously 95 is closer to 100, and you should use this table here. Use this row, excuse me. Okay. Good. Okay, 5 minutes to finish up. Perfect. We can do chapter 9, our last 2 days. Perfect. Okay. So, interval estimate. So, this format should look familiar. We have x bar plus or minus the standard error, which is exactly the same as it is with the z distribution. We're just substituting where it said z, we have t, and where it said sigma, we have s. Otherwise, it is exactly the same. So 1 minus alpha still works the same. T alpha over 2 is the same definition. It's just the t value instead of the z value, providing an area of alpha over 2 in the upper tail of a t distribution within -1 degrees of freedom. Yeah, I'm going to get a beatbox sometime. When I talk to the t value that provides an area. I don't know. I think I'm going to make a Gangster's Paradise. That's going to be the beat for sure. Working with the students' distribution. We've been spending most our lives taking samples for a t distribution. T distribution. Gotta get the rhythm right. I'll figure it out. I'll get it. All right. S and N. Sample standard deviation and N. Same thing. Same idea. Practice problem. A reporter for a student newspaper is writing an article on the cost of off-campus housing. A sample of 16 one-bedroom apartments within a half-mile radius of campus resulted in a sample mean of $750 per month and a sample standard deviation of $55. Let us provide a 95% confidence interval estimate of the mean rent per month for the population of one-bedroom apartments within a half-mile of campus. We will assume this population to be normally distributed. All right, so we need to identify key numbers. Generally, we've got dollar signs. That makes things easy. I'll just sort of 16. Right, what happened there? Did you see that? It just absolutely spazzed out. Unfortunately, I cannot. Oh, that's not it. Okay. I wish you could just hit the undo button, but it doesn't work. Okay, 16. Sample of 16. Okay, n equals 16. Sample mean of 750. Sample standard deviation of 55. Okay, so that means we're going to have 750 plus or minus something. We haven't found the t value yet, so some t with, and then it's going to be multiplied by our standard deviation of 55 over the square root of 16, right? So 750 goes there. Sample size goes there, and standard deviation goes there, right? So take those values and plug it in. Now we need the t. We still need the t, so we're going to need to use 95, and we're going to use 16. So we need all of these things to compute this estimate. I know it's kind of a hot mess, so I'll clear the screen off. But that's the process. So circle your keywords, plug it in the formula, and then go get yourself your t value from the table. So we have 95% confidence. So alpha is 0.05, and the area in the upper tail, which is alpha over 2, is 0.025. So we are going to be looking in the 0.025 column. This is the area, 0.025, and our degrees of freedom. Now, remember, what is the degrees of freedom? It's one fewer than your sample size. So 16 minus 1 equals 15, and so we have zoomed the table to fit so that the top line is 15. But of course, so don't be fooled. Don't choose 16. I know it's tempting. Don't do it. Don't do it. 15. 15, 15, 15. N minus 1. 15. 15 with an associated probability of 0.025 will give us 2.131. So this is our t value that we plug in our formula. Just like that. Okay. So plug it in. 750 plus or minus 2.131 times 55 over square root of 16, which of course we already plugged in the first three values. We just needed to add in that 2.131. So that's it. And then you type it in your calculator. Nice and easy. Now again, 16 square root's pretty easy, but just for the practice of doing it, 16 square root 4, add it to the memory, and then 2.131 times 55 divided by memory recall, 29.30125. 29.30, and that will be our margin of error. Oop, wrong way. And there it is, 29.30. Of course, you can just do square root of 4 in your head, I'm sure. If you want, it's fine. I just need you to get the answer. That's what matters. There's your margin of error. And by the way, for most of the time, sometimes questions will just ask you for the margin of error because this is a perfectly valid expression for the confidence interval. It's 750 plus or minus 29.3. That is perfectly reasonable as an answer to the question, what is your confidence interval? Or you can actually do the subtraction and the addition, and so you can say that we're 95% confident that the mean rent per month for the population is between 720.7 and 779.30. Both of those are valid. Both of them are valid, and so depending on your context and your problem and what you're doing, one may be better or the other. Okay, perfect. Okay, we're 1 minute over. Sorry to hold you over a little bit, but that's where I wanted to stop. We're going to skip the adequate sample size thing. It's an algebraic rewrite, and it's not key to the concept, so perfect. We're done with Chapter 8. We'll pick up with Chapter 9 on Wednesday. Don't forget that you've got a homework. If you haven't done Chapter 7, that is due on Wednesday. Let me just pull up those, just a little quick recap. Chapter 7 is due on Wednesday. I'll have Chapter 8 posted for you in a little bit, but you don't have to worry about it right now. But you're done with Chapter 8, so you can get working on that. We'll start with Chapter 9 on Wednesday. So Chapter 9 vocab on Wednesday, Chapter 7 if you haven't already done it. And if you haven't gotten your Mind Tap working, again, try the instructions. Make sure you log in directly to Cengage. Don't go through D2L. Just open a browser, Cengage Unlimited. You'll find it. If that doesn't work, contact this customer support. I'm sorry, I don't know how to help you. But please tell me how you fix it, because I want to know. But I don't know. I want to. I want to help. I do. But I have no idea. So please tell me what they tell you, and I will disseminate. Okay, that's everything. See you on Wednesday. Peace.